Now the thing about finding the range is you kind of got to think about the domain a little bit. But really you just have to think about the range, right? Now in 20, does it say you have to find the range algebraically? What does the textbook say you have to do? Just find the range. Alright. So to find the range, we're talking about the y values. Okay? So the y values are based on different principles. Instead of worrying about vertical asymptotes, we worry about horizontal asymptotes. So horizontal asymptotes usually occur as an item approaches infinity or negative infinity. Alright? So let's look at this. I'm going to rewrite this. Can I do this? I like to write things like this. Can I say x squared plus 3 all over negative x squared plus 4? Can I rewrite it? Is that the same thing?
Yep.
And can I do this too? Can I plug in here 1 over 1? Now here's a fancy notation, and I'll teach this in greater detail towards the end of the school year. But have you guys ever seen something like this? The limit of a function as the function approaches infinity of 1x squared plus 3 all over negative 1x squared plus 1, or 4 I mean. Do you know what that means? That means we're going to study the behavior as x approaches infinity. Now before I graph this, I already know the answer. There's a horizontal asymptote at negative 1. I know that because I'm a math teacher and I have the answers in the book, but I also know that because there's a trick to this. If I plug in 10,000 for x on the top and 10,000 for x on the bottom, I'm going to get 10,000 squared times 1 and 10,000 squared times negative 1 on the bottom. And the 3 and 4, let's just say they're so small it doesn't have that much of an impact on the value. So what would that be? Well, it'd basically be 10,000 squared, and let's think about this. So this is us thinking, and I'm going to write down our thinking so we can see our thinking. It's basically 10,000 squared over negative 10,000 squared, right? And, you know, plus 3 plus 4, we're going to ignore that. This is so small, just so we can estimate what this value will look like as we approach infinity. Well, what does this reduce down to? Negative 1, right? Well, now let's assume I plug in 1,000,000. Well, 1,000,000's a big number, and when I take 1,000,000 and I square it, again, the plus 3 and plus 4 on the bottom, that's really kind of insignificant, right? So what would that reduce down to? Negative 1. So now if I take the same equation and I look at the limit as I approach negative infinity, what I'm going to do is I'm going to take the same function, but now I'm going to plug in negative values going in the other direction. So just so you guys can see what I'm thinking, this is infinity, this is 0, this is negative infinity. And what I'm doing is I'm looking at the behavior as x increases in this direction. So if I go towards infinity, 10,000 isn't quite infinity, but it's in that direction. If I go further in that direction, 1,000,000 isn't quite infinity, but I'm going closer and closer towards infinity. And what we see is a pattern here that no matter how far I go in this direction, it seems like the ratio between the top, or the numerator, and the denominator will reduce down to close to negative 1. Right? Well, when I approach in the negative direction, right, when I go this way, I'm going to do the same thing, except now I'm going to have negative 1,000,000 squared over negative 1,000,000. Right? And so what happens there? It still reduces to, well, wait, that's a little different. And when I square this, I'll get a positive on the top And I get when I square this, I get a positive times a negative. It's still negative 1, isn't it? Is that true? So now, where would my horizontal asymptote occur? My horizontal asymptote should occur at negative 1. Let's graph this and see. So here's the trick. What degree polynomial is in the numerator? What degree is that polynomial? Second degree polynomial. What degree is this polynomial? Second degree. They're the same degree. What's the leading coefficients? 1 over negative 1, which reduces down to negative 1, negative 1, negative 1. So let's graph it and see what it looks like. Mind blown. Here we go. 3, and I'll enter it just the way it is in the book, just to make sure that Mr. Adams didn't goof it up too bad. And then 4 minus x squared. Here's my graph. Whoa! Now there's some crazy business here, right? Because when we say 4 minus x squared, we get the, for the domain we have a problem. But what is it asking us about? The range. The range. So let's see here. If I hit trace and I go all the way as far as I can to the left, we always want to approach towards negative infinity. So as my x goes further and further towards negative infinity, what do you notice about the y value? It gets really, really close to what number? Negative 1. But it'll never be negative 1. Do you guys understand that? Now as I go all the way to the right, it'll take a second to get there. What do you notice, Matt? What value is it approaching as I approach infinity in the x direction? What is the y value approaching?
10, 9.7.
No, that's the x value.
My bad. Negative 1.
Negative 1. Okay. So then what I said was true, right? We have a vertical or a horizontal asymptote at 1. But what do you notice about the graph? What do you notice about the graph? Well, as I come in here, there's some funny business right here. What is the lowest value this appears to be right here? 0.75. So if let's graph this, okay? So I've got a graph that goes like this. I have a vertical asymptote at 2 and negative 2. So we can't ignore vertical asymptotes. Now, does anybody remember why we have a vertical asymptote at 2 and negative 2? Well, it goes back to our denominator, okay? Our denominator is this right here, and that cannot equal 0. So 4 minus x squared 4 minus x squared cannot equal 0. But if I factor this, it's 2 plus x times the quantity, 2 minus x cannot equal 0. If I solve both of those for 0, we get x cannot equal 2 and x cannot equal negative 2. So when I come in here at x equals -2 and x equals +2, I now have vertical isotopes. Okay? Now, what does that mean? Well, it means that my function that's a minus x squared. What's the lowest value for x that I could have? Well, look at the x squared. You've got 2x squareds here. If I plug in a -1 for x squared and a -1 for x squared, what happens when I square the -1? I'm going to add them, right? It'll be positive, and so I'd have like 3 + 1 over 4 - 1. So the lowest value that I can have would be when x equals 0, because then I get 3 + 0 and 4 - 0. What's that equal? So finding the vertical and horizontal isotopes are very helpful, but sometimes we got to just look at the numbers too, right? There's a lot of things in this equation. That's why we're asked to do it algebraically and graphically. Now, if you were just to do it graphically, which the book says is okay, how would you write that? Well, let's look at the graph. I've got values coming from here to here, values that come through here, and values coming through from here to here. So now we got to look only in the y direction. You could turn your graph sideways like this and do it this way, right? Because in the y direction, this is negative, well, I'm writing it sideways, but this is negative infinity and this is positive infinity in the y direction, right? So what do I write for my range? Well, what's the lowest value for y I can have? Negative infinity. What does that come up to? Look at it this way. No, look at it this way. We're thinking in y's. Here's a point, here's a point, here's a point, here's a point. All those points are x comma y. What is the lowest y value I could have? Negative infinity. What is the next, like what's the highest y value I can have on this portion of the curve? Look at the graph. Let me show you on the graph. If I keep going this way, what is my y value doing? Decreasing. How far would that go? All the way to negative infinity. Now if I come back this way, what is my y value approaching? Totally ignore the x and look at the y. What is it approaching? -1. You guys with me so far? Now we're not done there. I got to go to the next section of the graph. So let's see where I'm coming in from there. Now here, on the top, if I go this way, how high up can y go? Yeah, to infinity, right? Positive infinity, that's the highest amount, but what's the lowest amount? 0.75 or 3/4. Does it go any lower than that? No. What was the highest amount? Did I include -1? No. Could I include 3/4? Yeah. Now what's the challenge with the range? What problem was that, 20? So that's the answer. And you might say to yourself, well, Mr. Adams, what about the stuff in between? Well, do we have any y values between 3/4 and -1? No, we don't. What does the range represent? All the possible y values from the lowest to the highest. Does that make sense? Any questions?